In the last section, we started to look at a couple of pretty simple trig limits. Here in this section, we're going to look at some infinite trig limits, but we're just going to do so graphically. So we're just going to draw the picture and then look at that just to recall how a few of these trig functions work. So here for this first one, I've got limit as x approaches 0 from the left of cosecant of x. We may not remember exactly what the graph of cosecant of x looks like, but we do know that cosecant of x is really just the reciprocal of sine of x, so it's 1 over sine of x. So I'm going to start this problem by graphing sine of x, and then once we have sine of x, cosecant of x should be I won't say easy, but it'll be easier to find once we have this reference point. So sine of x, what this looks like, I know it passes through the origin, and then we'll say, okay, here's a maximum, here's a minimum. Sine of x looks something like this. Here would be, pi over 2. Over here we've got negative pi over 2, and then this is a y value of 1 and negative 1 right here. So I know that sine of x looks something like this, and if you wanted to keep drawing it right, it just oscillates like that forever, but we really just care about the behavior close to 0. So that's going to be what we focus on here. So this is y equals sine of x. So if I want to come up with the graph of cosecant of x, its reciprocal, I would start with the behavior at -1 and +1, just because those are really nice to work with here. Reciprocal just means I'm going to take 1 divided by that number. So 1 divided by 1 would just be 1. So the graph of cosecant is actually also going to pass through pi over 2, comma 1. And 1 divided by -1, that's also going to be -1. So it's also going to pass through this point over here as well. And I want to know the behavior close to 0, remember, that's really what I'm interested in. So I might think about, okay, what happens if I pick a number close to 0? So I'm going to start with, say, 1/10. If I take 1 divided by 1/10, that's the same as saying 1 times the reciprocal, which is 10 over 1, so this would be 10. So this point that's right here on sine of x would actually be way up there for cosecant of x. So hopefully that gives us an idea of what this would look like then. We'd actually have something that looks like this for our right-hand side. And for the left-hand side, it's going to work very similarly, except here we have negative numbers. 1 divided by a negative number is going to give me a negative, so it should look something like this. Once we have the graph, evaluating this limit, I think, becomes a whole lot easier. So if I want to look at the limit as x approaches 0 from the left of cosecant of x, keeping in mind that's our red function here. So 0 from the left-hand side, I'm looking at this part of my function. Here it's decreasing, it's going down forever. So in this case, we would say that this limit is -infinity here. So we just need to look at the graph, and once we've got that, we should be able to identify any vertical asymptotes that we might have. The next one is the graph of tangent of x. Here I will have limit as theta approaches pi over 2 from the right of 1/3 tangent of theta. And if you're unfamiliar with tangent of theta, you may want to go back and brush up on those. But if you were to graph tangent of theta, what you would see... So I'm not going to worry about the 1/3 right there. Y equals tangent of theta here. Tangent of theta has vertical asymptotes at pi over 2, at 3 pi over 2, at 5 pi over 2, and so on. And then also for the negative direction as well. This has a vertical asymptote at negative pi over 2, negative 3 pi over 2, etc. And what's nice about all these trig functions is once you figure out how it behaves in one area, you kind of get the rest for free. Once you understand one period of that graph, the rest of it is just the same thing repeated over and over again. So at each of these points that I've labeled here, I have a vertical asymptote here. So I've got one here, I've got one here, I've got one here, here, and here. And so for tangent of theta, let's do that in Let's do that in a red so it stands out a little bit more. I know it passes through 0, 0. It's positive in the first quadrant, so from 0 to pi over 2 it's positive, so it's got to look like this. Negative in the fourth quadrant, so it would look something like this. And then it just repeats that pattern over and over again. So between every single one of these vertical asymptotes, I have this same graph over and over and over again. Now you might be worried about this 1/3. Remember that 1/3, if you really wanted to, you could say, okay, well, let's deal with that. I have limit as theta approaches pi over 2 from the right-hand side, 1/3 tangent of theta. Remember that 1/3, that's a constant multiple. We can factor that out. 1/3 times the limit as theta approaches pi over 2 from the right-hand side of tangent of theta. We'll worry about that 1/3 later. Now I'm just going to look at, well, what is this guy right here? So that, pi, as I approach pi over 2 from the right-hand side here, as I approach pi over 2 from the right-hand side here, once again, my function is going downward. It is decreasing without bounds as I approach from that right-hand side. So in this case, it approaches negative infinity. But I can't really forget about this guy, this 1/3. It seems like it should still be important. So I think about this here. I don't like to do this too often, but I'm going to do a little bit of math with positive and negative infinity. Here I've got 1/3 times negative infinity. If I take any number times infinity, it would still be infinity. Really, the only thing that could possibly change is the sign. But here I have a positive number times a negative number, should still be negative infinity. So I would caution you on doing too much math or too much computation with positive and negative infinity. It follows some of the same rules, so we can check the sign of, say, positive and negative infinity, but remember that positive and negative infinity are not real numbers. They do not follow the same rules as all other real numbers, so sometimes they behave in ways that you don't expect them to. So don't try and do too much math here with positive and negative infinity. If you just want to check the signs, though, that's going to be fine.